Welcome to What's New in Siemens NX. In this video, we're going to be taking a look at the latest enhancements to subtractive manufacturing. And to take us through the demo, let's hand over to Joe.
For this part of the demo, I'll be taking this really nice organic looking additively manufactured bracket and putting it into the NX manufacturing application to do all the finished machining. The component you can see here is the part that was designed by Paul using the latest topology optimization technology, but I'll also be working with the data that was created in the AM application by Ashley, and this will be the physical condition of supply that the shop floor will be receiving to machine. Let me change the view to show you all the components I'll be using for the final machining within NX CAM. We have the design part. This is what we'll be machining to. Here is the condition of supply part, which Ashley de-featured in the AM application, and this is the part we'll be machining. We've got the standard vice fixture for the machine tool, and we've also got this custom fixturing to hold the AM component. Because the part is not very prismatic and is very organic in its geometry, it's important that we design the correct fixturing to hold the component in the correct orientation for machining. These fixtures can be additively manufactured at the same time as the additively manufactured component, or machined in situ on the machine tool itself. So let's jump into CAM and take a look how I finish machining this component. This is the manufacturing setup that I've created. You can see that we're working in the context of the machine tool. It's really important to work within the context of the machine tool so that we can validate all the kinematics and simulate the machining the part correctly and accurately. You can also see that we've got our component mounted in the custom fixturing, which in turn is located in the standard vise that clamps directly to the bed of the machine tool. A real benefit of NX CAM is having access to what we call PostHub. PostHub is a platform hosting an extensive library that we can log into and download one of thousands of post processors available to us to meet the needs of your machine tools on the shop floor. Here we have the Smart Machine Toolkits. Smart Machine Toolkits not only give us a working post processor, but also give us the full machine tool graphics and a simulation driver which enables us to validate and simulate the NC code. So for this example, I'll choose the HAS-UMC and simply and dynamically download that Smart Machine Toolkit directly into NX. Next, we'll take a look at the machine operations required to finish machine the key features of this additively manufactured component. The machine operations are really simple to create in NX and work really well with the data that came directly out of the additive manufacturing environment. Let's take a look at the first two milling operations that we're going to use. Firstly, to remove the extra material from the part, I'm going to use a dynamic roughing toolpath. And secondly, a helical hole milling toolpath to open up the holes. Let's take a look at the material being removed so you can get a better understanding of how CAM toolpaths work. So, with minimal input, we're able to create these really optimized machining toolpaths to remove the remainder of material from the bottom of the hole of the additive component. Using the same tool, we can then open up the hole from the reference size that came off the printer itself to the finished design size of the component. The next thing we need to do is look at the 12 holes that need to be drilled and machined to finish size. You can see we've got some PMI attached to these three holes. These three holes have a tolerance against them, a limit of fit in fact, because they're locator holes and require a tighter tolerance to fit dowels during assembly. What I'm about to show you is process automation within NX CAM. What NX CAM can do is look at the features on our component and decide which tools and which operation types are best suited to machine those features. As well as that, NX will read in the PMI data and tolerances to directly influence which operations are needed to meet those tolerance requirements. Let's take a look at these features in the Feature Navigator. As we can see, NX has found all 12 of the holes and identified 3 of them as having PMI data against them. If we take a look at the holes without PMI, we can see that these 3 holes, NX has decided to create a spot drilling operation followed by a drilling operation, and the drill will be the finished size to finish the hole. Let's take a quick look at those operations being machined. Firstly, we see the spot drilling, followed by the drill, and that drill will finish those holes to size. If we go back to the Feature Navigator and take a look at the holes that have PMI attached to them, and if I go and find the related operations, this time you'll see that NX has created 3 machining operations. It's created a spot drill operation to spot the holes. It's created a drilling operation using a slightly smaller tool this time, and then it's finishing the hole size with a boring tool to the tolerance that the PMI has defined. And this is a great example of how intelligence from the design side of NX can drive the automation of the manufacturing side as well. Let's take a quick look at what that looks like. So again, we can see the spot drill, followed by the drill again, drilling slightly smaller, and finally we can see the boring tool coming in and finishing the diamond to those holes to tolerance. So finally, let's take a look at how we validate the program that's being created. It's really important that the NC code that's going to run on the physical machine on the shop floor can be validated and checked to ensure that there's no gouges, no collisions, and that the tool path is of a high quality. To do that, we utilize our machine tool simulation. Earlier on, we downloaded the Smart Machine Toolkit, which contained the machine graphics to give us context of the machine, as well as the post processor, so that we can output to the machine tool that matches what we have on the shop floor. But what it also gave us was a simulation driver, and that simulation driver is going to verify and validate that the toolpath is collision-free and safe before we use it on the shop floor. On the right-hand side of the simulation, you'll see that the post-processed NC code is running down in just the same way as it will on the CNC controller. And that NC code is driving the machine tool kinematics in NX to give a true digital twin validation of the CAM program, including material removal and a much more accurate machining time. NX is the only CAM tool that offers integrated NC simulation and is a fantastic way of validating and ensuring a safe collision-free toolpath. This concludes the portion of the demo regarding the finished machining in NX CAM. And what we've seen today is how we can take both data from design and also data directly out of the AM application to create custom fixturing to hold that component and to validate the NC program that has been created to finish machine these components.
Thanks for joining us today. If you'd like to check out the full workflow for this demo, I'd recommend taking a look at the What's New in Siemens NX YouTube premiere at the end of this video. We hope you enjoyed it today, and we'll see you in the next one.